All right, friends, let's take a look here at our practice problems for Newton's second law, the relationship between force, mass, and acceleration. You have a couple summary problems from the notes. Hopefully those are already done. Just going to review those with you quickly. Here we're looking at how changing the mass of an object impacts acceleration. So in this example, we are increasing the mass. What does that do to acceleration? So I'm thinking about an example with my girls, right? I've got two kids. We have two strollers at my house, a single stroller and a double stroller. When I'm pushing one daughter, my younger one, in the stroller, she weighs 25 pounds, okay? When I'm pushing both of them in the stroller, now I have 25 plus 50 pounds. So I'm looking at 75 pounds in the second stroller. I know it's much more difficult to move the object with more mass, therefore it has less acceleration. It's harder to speed it up and slow it down. I would much rather over here push just the one daughter in the single stroller. So by increasing the mass, I am lowering the object's acceleration. Cool. The second one here, how does increasing the force change an object's acceleration? So let's go back to the stroller example. If I'm just pushing the single daughter with different forces, what's that going to do to her acceleration? So if I'm pushing, again, the one daughter, the 25 pounds, with like a walking type of a force in the stroller compared to an increased force where I'm running, pushing it with a stronger force, obviously the acceleration is going to increase as I increase that force. The more force I put on the object, the more the object is going to accelerate. Okay? And then we've got a couple problems to calculate force, mass, acceleration. You've got this in the homework check coming up. You also have this on the unit ending quiz. So be prepared for that. I know in the notes we went through kind of how to set these up. I know Mr. Mahadi gave you a setup as well. So I'm going to go a little bit faster, just kind of crushing through to make sure you've got the right answer. So I'll read the problem and set it up. So here we're starting with problem number 1. Check your answer on each one. So here we're looking at a helicopter with a mass of 4,500 kilograms and a net force of 18,000 newtons. I need to then calculate acceleration. So the first thing I have to decide is what formula am I using. If I'm calculating for acceleration, am I looking to solve for force, mass, or acceleration? So I need that third problem here. And you will have these available to you both on the homework check and the quiz. So you don't need to memorize the formula, you just want to be able to use it. So if I'm solving for acceleration, I need to know my force and I need to know my mass. So here my mass is 4,500 kgs and my force is 18,000 newtons. And then I'm going to plug that into the calculator. Again, you'll have a calculator available both on the homework check and the quiz. You plug that in, 18,000 divided by 4,500, that's going to give you an answer of 4. And then my unit for acceleration is meters per second squared. So kind of like net force, we need two parts. Net force, we had the value and the direction. Here for all of our calculations, we need the numerical answer and the unit, and those need to go together, so be careful with that. Number 2 here, split by the page, but we still can solve it. Looking at our problem, we want to calculate net force. We know the mass of the dragster, which is a racing car. We know the mass is 900 kilograms and its acceleration is 32 meters per second. So I'm solving for net force. Looking at my formulas, I need to solve for F. So I've got force equals ma. And in math, remember, when there's no symbol, they're being multiplied together. So I've got to solve for force, and I want to find the mass and the acceleration. So mass is 900 kilograms. Acceleration is 32 meters per second squared. So again, I'm plugging those into the calculator, and I'm going to get a force of 28,000, and my unit for force is newtons. Cool. Number 3, a car pulled by a tow truck has an acceleration of 2 meters per second squared. I need to calculate the mass of the car. So I am solving for mass. I need to calculate the mass of the car if the net force on the car is 3,000. So I'm solving for mass. Looking back at my formulas here, I need to use this guy. Force divided by acceleration. So I'm setting that up. Force divided by acceleration. Force of 3,000. And acceleration of 2.0. So again, plugging that into the calculator, I am solving out for a mass of 1,500 kilograms. Great. Here, number 4, I've got a car that is 50 kilograms set on cruise control going down the highway with a constant speed, not changing the speed or direction. Calculate the net force required to keep the object moving at that speed. So I need to solve for net force. Again, going back to my problems up here, I'm solving for force. So I need the force equals mass times acceleration. Right? So here I have force. I know the mass is 50 kilograms. And then acceleration, I don't have another number. But I do have some information about the acceleration of a car. Remember, the acceleration is an increase or a decrease in speed or a change in direction. So I don't have a value, numerical value in my problem, but I know about the speed and I know about the direction of the car. It's going a constant speed, no change to speed or direction. So that means it's not accelerating. So then what we have to think about is what number can we use to state that the car is not accelerating. So when I'm talking a numerical value of nothing, that's of course going to be 0. So here I've got force equals 50 times 0, which is of course 0 newtons, which brings us back to Newton's first law. How much force is required to keep the object in motion? It's already in motion. It's going to keep going in that same motion infinitely until an unbalanced force acts on it. So I don't need any any force to keep it moving. It will continue to do so. Had to make you think a little bit on that last one. Here, number 5, you get a little creative freedom to make your own word problem. So you want to choose a formula that you're going to use. So you get to decide, are you going to solve for mass, force, or acceleration? And you're going to write out the scenario. So you're going to pick the object, whatever it is, moving, give a mass. I guess that's going to differ. So just make sure you include mass, force and acceleration in your problem, giving two values and then stating you're solving for the other, right? So pick your object. It can be a person, it can be an animal, it can be inanimate like the car or a boat or a ball, something like that. We aren't going to critique your values. So if you're stressing out, I don't know the mass of a car, or I don't know what's an appropriate number of newtons, those are not going to get critiqued, okay? We just want to see that you can set it up and include the appropriate values and variables for the formula that you choose, okay? And notice it says you don't need to solve. You're just creating the problem so someone else could solve it down the line, okay? Everyone's going to have something a little different down here, so I'm going to let you kind of answer those as you watched the video. As always, shoot your teacher a message if you have a specific question, and one of these screenshots included with your questions are super, super helpful. All right, crush that.